So, what if you could actually predict the future? Like next month's sales figures, or tomorrow's stock price, maybe even next week's energy demand. Well, the key to all of this, it lies in understanding data that's collected over time. We call this time series data. And believe me, mastering it is absolutely fundamental if you want to forecast what's coming next.
Okay, so here's what we're going to cover. First, we'll define what time series data actually is. Then, we'll get into the art of forecasting itself. After that, we'll deconstruct a time series into its core parts, look at some real-world applications, and finally, I'll give you a solid summary for your exams.
All right, let's dive right in. First up, defining time series data.
So what are we talking about here? Well, a time series is basically a sequence of data points that are collected at regular intervals, right? It could be hourly, daily, monthly, yearly. You get the picture. Think about a company's monthly sales reports, or the daily closing price of a stock, or even something like hourly temperature readings. The absolutely critical part here is that every single data point is tied to a specific moment in time. It creates this chronological story. And this is so important. That sequential nature is honestly the #1 property of time series data. You have January sales, then February's, then March's. It's all in a very specific order. I mean, what would happen if we just shuffled all those points around? The data would be completely meaningless, right? The context of what came before and what's coming next, that's literally everything. Okay, so we know what time series data is. Now, the big question is, what can we actually do with it? Well, that brings us right to the art of forecasting. This right here, this is the whole goal. Simply put, time series forecasting is all about using historical data to predict what's going to happen in the future. We're looking at past patterns, past trends, past behaviors, and using all of that to make smart, data-driven guesses about what's just around the corner. And this visual makes it super clear. That solid line? That's our known history. It's all the data we've already collected and logged. But that dotted line, that is our forecast. It's our prediction, extending that historical pattern into the future. And really, the main job of any forecasting model is to draw that dotted line as accurately as it possibly can. But here's the thing. Making a good forecast isn't as simple as just drawing a line. To get it right, we really have to understand the underlying structure of the data itself. And to do that, we need to deconstruct the time series. It turns out that pretty much any time series can be broken down or decomposed into 4 main components. And why do we do this? Well, it's absolutely crucial, because if we can model each of these pieces separately, we can build a forecast that is way more accurate and way more robust. So let's break them down one by one. First up, we've got the trend. Think of this as the long-term underlying direction of the data. Over a long period, is it generally going up? Is it going down? Or is it staying flat? For example, think about a growing company's revenue over, say, 5 years. That upward slope is the trend. It's the big picture view of where things are heading. Okay, next up is seasonal variation. Now, these are patterns that repeat themselves at fixed, predictable intervals of time. The classic example everyone uses is ice cream sales, right? They always peak in the summer and then drop in the winter. That pattern repeats like clockwork, year after year. That's seasonality. Then we have cyclical variation. Now, this one is easy to mix up with seasonal patterns, but there's a key difference: the timescale and the regularity. Cyclical patterns are also these waves of ups and downs, but they happen over much longer, and importantly, irregular periods. We're talking several years often. The best example is broad economic cycles, those periods of boom and bust, or expansion and recession. So let's just nail down this distinction because it's super important. Seasonal patterns, they're short-term and regular. Think about the 4 seasons in a year, predictable. Cyclical patterns, they're long-term and irregular, like trying to predict exactly how long an economic boom will last. You can't. And trust me, getting this right is absolutely vital if you want to build an accurate model. And last but not least, we have irregular variation. You could just think of this as the random noise. It's the unpredictable stuff, the fluctuations that are left over after we've already accounted for the trend, the seasonal, and the cyclical parts. What causes this? Well, usually it's sudden, one-off events, things like a natural disaster or a big, unexpected policy change. Okay, so that's the theory. We've got the building blocks. Now let's talk about where this stuff is actually used. Let's look at forecasting in the real world. And the applications are, well, they're everywhere. Seriously, businesses use it all the time to forecast sales. This helps them make sure they have enough inventory, but not too much. Energy companies are constantly predicting electricity demand so we don't have blackouts during a heat wave. Of course, in finance, it's used to try and model stock prices. And hey, even meteorologists use it for weather prediction. It is a critical tool for planning and optimization in just about any industry you can think of. So this brings up a good question. Why is this so important? I mean, why do big organizations pour so much time and money into getting these predictions right? Well, it really all boils down to one thing: making better decisions. If you can analyze the past to get a good glimpse of the future, you can plan your resources way more effectively. You can anticipate shifts in the market before they happen, and ultimately, you can reduce the uncertainty and the risk in your day-to-day operations. It's really about shifting from just reacting to what's happening now to proactively preparing for what's coming next. All right, time to pull all of this together. Let's create a solid summary, especially for those of you preparing for exams. If you get a 5 or 10 mark question on this, here's what you need to know. So how do you nail this on your exam? Let me show you what a perfect answer looks like. Okay, for a top scoring answer, you're going to want to structure it just like this. Start with the core definition. A time series is a set of observations recorded sequentially over time at regular intervals. Got it? Good. Second, define time series forecasting. It's the process of analyzing that historical data to identify patterns and predict future values. And then, and this is the real meat of the answer, you have to list and explain the 4 components: trend, seasonal variation, cyclical variation, and irregular variation. If you lay it out like that, you've covered all the key points they're looking for. And, to make sure you don't blank out on these components during the exam, I've got a simple little memory trick for you. All you need to remember is TSCI. That's TSCI. T is for trend, that's the long-term movement. S is for seasonal, those are the fixed repeating patterns. C is for cyclical, the long-term, non-fixed cycles. And finally, I is for irregular, the random, unpredictable events. Just lock TSCI in your brain and you're golden. So when you boil it all down, time series forecasting is really a structured way to learn from the past so you can navigate the future. It's this amazing tool for turning total uncertainty into a calculated risk. So the final question I want to leave you with is this. With historical data as our guide, what future can you now predict? And more importantly, prepare for?